Here I'm going to go through the answers on this paper. Please make sure you've done the paper first before you look at the answers. So, when magnesium burns, it transfers heat and light to the surroundings. We say this is an exothermic because it's given heat and light, it's given energy out. Complete the word equation. Magnesium add oxygen will make magnesium oxide. Which acid should then the student add to sodium hydroxide to make sodium sulfate? Well, if I want to make a sulfate, I'm going to need sulfuric acid. So sodium sulfate. Well, sodium is group 1, so it will lose 1 electron and become Na+. Sulfate is SO4 and it's a 2 negative. So can I have NaSO4? No, I can't because I've got 1 positive and 2 negative. So actually I need 2 lots of Na plus to balance that out. So my formula would be Na2SO4. The next question is a bit of a giveaway. So notice that the solution in the beaker got warm. It's getting warm. Well, that's telling me instantly it is exothermic. And in terms of energy, what type? Yeah, it's exothermic. I can also see that because I go from reactants and down here to products. So my energy change is negative, therefore it's exothermic. Use the energy diagram to calculate the value for the amount of energy released. Kind of just done that. So it says one large division is 10 kilograms. So we've gone from 1, 2, 3, 4, 5. We've got 6 jumps from there to there. So therefore it is 60 kilojoules. This is a bit of a better question, testing a bit more of understanding. So it says explain. So why? Bond breaking and bond forming. So if you don't use that language, then you're not going to get the marks. So energy is given out when we have bond forming, and energy is taken in when we have bond breaking. So if overall energy is released, it must mean bond forming is greater than bond breaking. If I explain that a bit more, I'm saying that the energy released from bond forming is greater than the energy taken in from bond breaking. The reaction takes place very quickly without a catalyst. What does it say about activation energy? It tells you that the activation energy is very low because most of the molecules already have enough energy to start reacting. Okay, so it says complete the diagram to show how you could collect the hydrogen produced. So hydrogen produced is a gas. So I need something to connect to gas, so I would use a gas syringe. Okay. I would also make sure it is graduated or calibrated so that I can see how much volume is being given off. When is the rate at its fastest? It's always at the fastest at the start. Why? Because this is when you've got the most reactants and therefore you've got the most frequent collisions. So one way she could increase the rate of reaction, you could increase the temperature, you could also increase the concentration, you could add a catalyst, you could increasing the pressure wouldn't work because your reactants aren't gases, and you could increase the surface area of the metal. What is the total volume of hydrogen collected in the experiment? So looking back at the previous page, looking at the graph, you will see it's 48. And state one way in which you could increase the final volume of hydrogen collected, well, you would need more magnesium. And more magnesium won't make it faster, it will just give you more at the end. Okay, so this question says you've got a piece of reactive metal and it's added to acid. So metal and acid form salt plus hydrogen. Which particle will probably react first? One inside, one in the centre of a face, or a corner? Well, your answer would probably be a corner one, okay? And the reason is simply because you've got more surface exposed to react. If it was a face, you'd only have one side, but the corner has got two sides, or even the bottom base is well exposed. Okay, so here's a classic rate of reaction question. State two ways to speed up the reaction by changing the acid and explain why. So one way is you could make the acid more concentrated. The reason this would help because you've got more particles in a space to collide. The second point I could increase the temperature of the acid. And the way this would help would be the particles move faster and therefore you get more collisions. But also the particles have more energy. Therefore there's more successful collisions because more of them have energy greater than activation energy. Okay, what change can you make to the solid to speed up the reaction and explain why? Well, you can give it more surface area, therefore you get more frequent collisions. Because there is more exposed surface. What is the formula for propane? Well, pro is 3, ane is single bonds, so it's that. Butane has that. Complete the formula. So 4 carbons and 10 hydrogens. Complete the word equation for complete combustion. So that's adding oxygen. We'll make carbon dioxide and water. And finally, smoke is produced. Explained why. Well, smoke is carbon. And this is formed when there is incomplete combustion. It's a classic question. How crude oil is separated? Well, first off, it's heated. Crude oil is heated. It is evaporated. And it condenses. Okay. The vapor condenses. Now, the reason it separates is because the fractions condense at different temperatures. And this is because the fractions have different boiling points. Okay, describe the trend. A trend is a pattern in boiling point and viscosity as the carbons increases. So as the carbons increase, the boiling point increases and the viscosity increases. This means it gets more gloopy. It says Propane, complete the structural formula for propane. Well, bond the hydrogens and make sure I make 8 hydrogens. Every carbon has 4 bonds. Next question, burning is combustion, 2 products. I'm going to assume it's complete, so my 2 products are carbon dioxide and water. So why don't we use this all the time? Well, because they're less available. So most cars are petrol cars, so therefore there's not many LPG cars, and that's because they're more expensive. Okay, so this is the experiment for how cracking works. So I'm starting here with decane, okay, here, and it's heated strongly, it's going to evaporate, and then it's going to go through here, and the octane is going to condense, and the other product is still a gas, so the other product will go through. Okay, so describe the process. Well, the first step is the decane will evaporate. The pottery acts as a catalyst, It's cracked or split. The decane is cracked, and it's cracked into octane and ethene, because notice that's double add 2. This is called thermal decomposition, because heat, thermal decomposition, it's broken down. And that's going to give you those 4 marks. So that's the end of the paper. Well done.